in Campinas. She
I
was before in Brasilia, the capital, but she moved to Campinas. So it is.
So they want we all want these collaborations not only in this case but actually with a lot of the global south.
This place in Brazil and
3 minutes. Yeah, we can and 3 minutes. Like, yeah, well, that way we are. Yeah, because it's the that.
Yeah, that's right.
Not already.
Then I call
that is about collaboration. Most involved in communities.
the problem we do have is we have this program, and we don't have the contacts to spread the news about these programs. In particular, have so much money and just randomly get people that are not necessarily the right people, right? So, and we have been there. They have very good information, but they have weird.
Yeah, I have to reach.
Just not the
It's really me too. It's really.
It's very.
So I should not throw it.
Yeah, you get it.
So I'm going just one summer school that I'm supposed to lecture, and I'm going to yes. Other than that,
All right. All right. Well, I'll probably do sending this email.
Great.
If I have time. And so there are people.
Yeah. I think some of us are easy to reach, but really other just don't know, and it's very hard to. We would need a lot of us to show season. There's just many.
I think in that respect, getting in touch with IMSA or our institute, because our institute also has a program of collaboration with Latin American countries, which for Spain is a more than thing.
Yes.
And so essentially, Spain operates as a intermediary to this people in Latin America.
Yeah.
Say it's
Yes. Yeah. I think that we could also for the African collaborations, it would be really important to have people who knows the place.
Someone, such a person, would be super in South Africa. With Nation goes regularly to South Africa to give courses. There's this African aims that he's inspired. So
now I feel obligated to ask.
yeah. No, that would be a great service.
And yesterday I received the notification for this sales key image. So now you guys know where it is, what time it is.
Shall we start? Okay, let us start the last session of the final speakers. We will talk about the Dolbeault Langlands for type groups beyond the elliptic. Please.
Thank you very much for the invitation. And as a last speaker, I'd like to thank the organizers for having such a wonderful workshop. So today I will talk about some information of the so-called Dolbeault Langlands conjecture, but I should confess that I'm not the expert about the Higgs bundles. And to be honest, until 2 years ago, so I never worked on Higgs bundles. And I rather recently worked on this because so far I was working on the Thomas invariance on Travis reports, derived categories, or so on. But recently, I'm interested in categorification of this invariant, and this has some interesting relation with the Dolbeault Langlands which I'm going to provide. So as I said, this is my motivation. So this is why I'm interested in the Higgs bundles. So my motivation is about the Thomas theory. This is in fact saves on various reports. So originally these are the some in integers. But I'm interested in categorifying these invariants. Categorify not only the vector space, but I want really the engine category or stable infinity category, which categorifies these invariants. So there are many motivations why I want to do this, but I don't talk it too much today. But one of the my interest is that so there are some mysterious phenomena in this theory called kite-related phenomena. So this is I found in 2008 or so on. So this is actually driven by computation, but its intrinsic understanding has been missing. On the other hand, from geometric Langlands, this is some duality of moduli space for local systems and vector bounds of curves. So this is the recently proven. And other it's classical limits. So there are some so-called Dolbeault Langlands. So this is some duality, some Higgs bounds. So this is very formulated and already proven, but this is not yet much developed compared with the original geometric Langlands. I think that the original motivation of Dolbeault Langlands is first proving this one and then apply it to prove this one. But this is proven first. But my opinion is that this is much more difficult and also much more interesting from in the viewpoint of algebraic geometry. So then we talk about the what is Dolbeault Langlands. So I think so. Yeah, many of you know that. So this is the moduli space Higgs boundaries. My setting is that it's most projective curve of G and its reductive group and its random neurons and the very positive down. So this is the most of the Higgs boundaries. And I denote by Higgs G. So this is the moduli stack of the Higgs boundaries. But the difference from other talks is that first I don't import stability functions. So that so this is quite a huge stack. This is not of each component is not of finite type. There are many infinite number of standards. Another difference is that I take the derived moduli space, but this is not much essential in many cases. For example, when genus is bigger than or equal to 2, and like for example like G to GA or BGA, then this is classical. So you don't have to worry about the derived structure in those cases. But the important stability condition, so this is a very important topic in my talk. So then, so we have the also Higgs vibrations. So if you compare Higgs vibration of the G and its Duncan dual, so then the Higgs bases are the same. So this is due to Donaki and Pantel, and they consider this diagram, and they showed that the genetic fibers so there are some days of offset where the spectral curve, when the GL case, when the P5 is taken to be where the spectral curves are smooth. And over this locus, so there are smooth vibrations, and in fact they are the dual vibrations. So then the classical Gudimukai theory implied that at least at the generic point, we have some equivalence with derived categories. So here I use this notation from the geometric Langlands group in the code of the nilpotent singular support, which I summarized here. But if you don't know about this one, then you can just imagine, say, you got it some sort of derived categories, which also keep track of some similarities of the moduli space. But of course, in the generic fiber is smooth, so you don't have to consider about this. You can just replace it like some quadruple headship, for example. But the Indo is that so this is Indo compression. So this is you also have the infinite whole product. So then the proposal by Donagi and Matev. So I write it as a quotation mark because I'm not sure whether this is true, still as it is. But what they proposed is that so this, and also when they proposed it, there is no such notion in the code for nilpotent singular support. So so they said that there's some sort of equivalence for some sort of. But anyways, if you use this language, then you might expect some equivalence of the derived categories with the moduli stack Higgs boundaries, with this one and this one, which extends to the Gudimukai equivalence for the generic fiber. But of course, the generic fiber is easy because this is some dual beam vibration. But of course, when you specialize, like when the spectral curves are quite highly singular, then the fibers are quite fibers are quite difficult to understand. This is quite difficult. Anyway, the motivation is to have the so-called classical limit of the geometric Langlands. So this is a statement of the geometric Langlands. So this is the modular stack of locus systems. So this is more for instance, this is the modular stack of G bundle with connection. And this is the D module of the modular stack of G bundles. So this is a statement first formulated by Adinki and Gesgri, and recently proven by Gesgri's research groups. So yes, so this is the statement, and the non-quantity proposal is that so they wanted to have this equivalence, constructing this equivalence, and they take the organization. But anyway, so the observation is that first, in the left-hand side, there's one parameter derivation of the stack of local systems to the modular stack of Higgs bundles. So this is the story of the non-average correspondence. And in the right-hand side, the D module is regarded as the deformation continuization of the sheaves on the cotangent. And the modular stack of Higgs bundles is, if you forget about the stability condition, this is the same as the cotangent stack, the modular stack of G bundles. The Higgs field gives the cotangent direction. And in if you consider the sheaves on the cotangent, then it has non-commutative deformation. It is a non-commutative algebra. So this non-commutative algebra, you can take the sheave definition of theta. So then by taking the classical limit of this process, you may get this one. So then they thought that there might be some equivalence. But as I say, this is in most of the cases, this is a torus. So let's consider the GL case and let's see what is happening here. So in the GL case, so another description of the Higgs bundle is that give a Langlands vector bundle, and also the data. This is the sheave, the map of the coherent sheave. So this is the Higgs field, and the Higgs map is just given this way. So the Higgs base is the right example of CI, and this Higgs map is given by the wave projection. And in this case, for this modular type the Higgs bundle is related to the modular space of one-dimensional shapes of the non-compact surface given by the total space of conical alignment of this curved shape. So this is like a non-compact KC surface, and this is the modular space of one-dimensional shapes, and this is something similar to the so-called four-dimensional system in KC surface. And from this description, if you are given a point of the Higgs base, there is so-called spectral curve. It corresponds to the support of the Higgs bundle in this cotangent space. And the Higgs fiber is identified with the modular stack of torsion-free sheaves with fundamental cycle. So in general, the Higgs fiber is quite complicated to understand, but the relatively amenable locus is so-called the elliptic locus. I think this name is first maybe mentioned by Ngo or Dolbeault. So I don't know the history, but anyway, so we have some open subset of the Higgs base where the spectral curve is the integral curve that is reduced and irreducible. So this is a little bit deeper locus where CB is used. But nevertheless, over this locus, the Higgs fiber is written by so-called compact Jacobian. So this is the modular space of rank 1 torsion-free sheaf on this integral curve. The point is that here, so because this is the spectral curve is irreducible, the stability condition is satisfied for D. Any torsion-free sheaf on this integral curve is automatically stable. So you don't have to worry about stability condition over this locus. What I think improved is that the Frey-Mukai equivalence over the smooth over the locus for smooth spectral curves can be extended to the locus with integral spectral curves. So here construct a certain Koremakuri extension of the so-called the Poincare line bundle, which gives the equivalence with the generic fibers. And then using the so-called the Koremakuri extension, then he showed the equivalence between the auto equivalence, the derived category of this compact fiber Jacobian. In particular, so his result implies that the Dolbeault Langlands is true over this locus. So, however, after he took this result, so there is no nice result beyond the elliptic locus. And in my opinion, so proving this equivalence beyond the elliptic locus is, at this moment, this seems hopeless. And probably I think this is not true. The reason is that this, compared with the categories which appeared in the geometric Langlands, so these categories are quite badly behaved. In fact, for any open subset which strictly contains the elliptic locus, that is when if it contains a point where the spectral curve is either reducible or not reduced, then this stack is a singular stack, not a scheme. Because that over the elliptic locus, the fibers are just the compacted Jacobian. But when the spectral curve is not reducible, not integral, so there might be some Higgs bundles, which is some direct sum of something, for example, if which all these things not integrated some values. But the more serious issue is that this is not quasi-compact. That is, because I don't put the stability conditions, this is contains infinite number of the hard-Nash standards, and which makes this category to be poor behaved. For example, this is not compactly generated. So this is a technical notion in the DG category, but this property is very important in proving the geometric Langlands in the story of the gate tree and story methods. In fact, before proving the geometric Langlands, we paid on the gate tree spent effort to prove the compact generations of the categories which appeared in the post site of the geometric Langlands. This is at this moment, I think, if the category is compactly generated, so there are many techniques which we can use. But otherwise, so we don't have not enough tube to attack this structure. But so I want to modify the conjecture which makes it more realistic and more reasonable to attack. And on the spectral side, well, there is a reasonable guess. That is, in the story of the Noabe-Hodge correspondence, instead of considering the modular stack without stability condition, of course, we can consider modular stack with stability condition. As I said, the reason why the Higgs bundle, modular stack Higgs bundle is not quite compact is that I didn't put stability conditions. But of course, we can consider the version with stability conditions. And in fact, now because of putting stability condition, this modular stack and this modular stack is very similar. That is, for example, if you compare the element of both sides in the quadratic group of stacks, then they are the same element. G equals 0. This is result by Dolbeault Langlands. And in fact, each component is now what? So that the result by Dolbeault Langlands. So this is compactly generated. So the question is that now whether there are some corresponding nice degeneration of the D module on the stack of the G bundles. So of course the naive guess is that we also want to consider the semi-stable part, but this is not the correct answer because in this formation still the G bundles, so there is no stability conditions. So but nevertheless, although 1G is 1G is also not very compact. So it is quite purely stack. But there is some miracle of considering the DD module. So this is very important result by Dolbeault and Gateway that although this is not quite compact, the category of D module is reasonably small so that it makes it compactly generated. So I'd like to find some nice or smaller degeneration which corresponds to the semi-stable degeneration in the spectral type. So this is the content of my talk. So the main thing which I want to talk is I want to give some answers. What is the data degeneration of the D modules, which we introduced as limit category? In fact, so this idea of considering this category is coming from the categorical DD theory. the categorization of the DT theory. And then using this new notion, try to give a new formulation of the Dolbeault Langlands in this way. The left-hand side is the category for the semi-stable expanded. But in the right-hand side, I would like to consider categories without stability conditions, but with some smaller category. So then upshot is that now we will see that these are now compactly generated, and we can extend the result of the Dolbeault Langlands so that the main result is that there are some open subset which strictly contains the elliptic locus, such that this version of the equivalence holds. And in fact, this version is not only essential for the formation, but also essential for the proof. In fact, we did many foundational work in the of this theory, and to see some relationship with the D modules and so on, which I will going to explain now. So now I'm going to explain what is the right-hand side, the automotive side. So the definition is a bit technical, so I just first give our definition in some rough way, and explain why this is naturally appeared in the context. So this is more general settings. Let them be quite smooth, derived stack with stereo potential complex. So then you can replace it with the modular stack Higgs bundles without stability conditions. And then also take some element of the apical group, line bundle of this modular stack. So then there is certain subcategory which I wrote here, and the precise definition is a little technical, but the most essential property is that for a perfect complex with a locally compact object, so it satisfies this weight condition. That is, for any map from a BGM to this stack, then the condition is that after taking pullback and then consider a set of GM weights, then it is contained in this region, in this interval. Here, so this is the partial class of the element of the sheaves on BGM. That is explicitly if you take the sheaf on BGM. So this is nothing but the GM representations. And you can take its weight decomposition, and its partial class. The negative part is the weighted sum over the negative part, and the positive part is also similarly defined. And this LM is a potential complex. So yeah, I will return to this definition later. But so we want to apply this construction when the stack is a potential type. That is, where X is a smooth stack, and then if you take the potential stack, then this is has the same dual tangent complex. And I expect so this gives a nice better integration of the modules. So this part is still conjecture, but we have several evidence for this. For example, these are the two simplest examples. So then X is the classifying stack of the reductive group G. Then we can compare the D module of the reductive group of the BG and also this construction. And in this case, so this is actually equivalent. So this means that if you consider the usual derived category of the cotangent of BG, then this is much bigger than the D modules. But giving some suitable smaller category, we actually get the equivalence. And both sides are generated by only one object. And by computing the algorithm algebra, this is actually equivalent to the cube of this the differential equated algebra with zero differential. So similarly, if consider X equal A1 over GM, so where GM acts on A1 by weight 1, then in here we have only 2 points, the generic point and the special point. And we have the two stratifications. And as is the case of the usual hyperbound shapes or constructed shapes, so if there are stratifications, then there is associated semi-squadratic composition. Such a semi-squadratic composition does not apply for the usual coherent shapes or quasi-coherent shapes. But this is the case for this category. In fact, in this case, it is also actually equivalent. And this admits semi-squadratic composition in this way. of course, in general, so they are engineers, they are not equivalent, but these are some special cases. But the other cases, we expect that so there are some nice one parameter simulation from here to here.
Sorry, is that first measure not depending on the group? Does it not depend on the group? For any G, it's just about
Any dimension of the capital superalgebra.
doesn't depend on the group that much, it's just a dimension of the carton.
Yeah. So yes, so yeah, I will go this. So this is the key point of the definition. And so first, this kind of weight condition appeared in other research areas. That is not Higgs boundary or geometric Langlands. In fact, so this is so a kind of deformation or generalization of the work by so this first appeared in Spenk and Vandenberg's work on the construction of the non-commutative preparatory resolution of some GIT quotient singularities. In their paper, so this is not explicit. So this condition, so their condition is different. This one, currently, say construct certain the representations of a reductive group whose highest weight is contained in certain weight point of. But we can deformate of their construction intrinsically to the quotient stack. And then this is the way how to interpret their constructions intrinsically to the stack. And also such a construction was also used hyperrealized sum. So they show that for certain birational Calabi manifolds, so there are some equivalents of derived categories. And recently in my project with Dolbeault, we also use this construction to categorify the so-called PPS invariants with this theory. Anyway, so this kind of weight condition has been natural in others also areas, but this is also natural in the context of Higgs boundaries. So this is so this is starting. This is very easy approach. That is, if you consider some spectral curve and consider the line boundary over here, given by so-called the linear pairing. So this is when the spectral curve is smooth, then this is nothing but the universal line boundary, which gives the equivalence of the derived categories of the Jacobians. Anyway, so this is the value of this line boundary over each point E and F is that given in this way. So then there is some quite interesting generalization, the semi-stability of the line boundary for the spectral curve. So if you take a line boundary of the spectral curve, degree W over this spectral curve. Then we can say that this line boundary is semi-stable or corresponds to semi-stable Higgs boundaries if and only if. So if you fix the line boundary, then under this correspondence, we can construct the line boundary over the Higgs fiber. So then the associated line boundary of the Higgs fiber satisfies the same weight condition which I mentioned before. So now this is the line boundary. So this is the weight is just only one element. But the point is that this is now if and only if statement. So this means that the weight condition is regarded as some sort of the real notion of the semi-stability under this the Dolbeault Langlands correspondence. So based on these observations, our proposal is this. So let's take chi in I1G, and let's take W. ZG is the center of the reductive group. And so this is the character of the center. So our proposal is that we have equivalence categories. The left-hand side is in the core for the modular semi-stable Higgs boundaries. And the right-hand side is the limit category without stability conditions. So here Higgs chi, so this is a connected component corresponding to chi. So when G equals 0 our case, so phi 1 and both are integer. And the chi corresponds to the degree of the Higgs boundaries, and the W is the GM weight corresponding to the central GM weight. So now the point is that now both sides are in fact compactly generated. So this is our proposal. So then I'm going to give some more comment about the background of this conjecture equivalence. First, this is about the vector side. That is in the form of the single support of the semi-stable Higgs boundaries. First, this is because I'm taking the semi-stable part, so this is now quasi-compact. And in that case, this is compact genetics. This is due to inflate against it. But we can interpret this category as some categorization of the mass Thomas field. That is, so when G equals G case, this moduli type of Higgs boundary is moduli space, non-compact case surface, like the product space with non-infinite boundary. But we can also calculate that, we can also show that this is equivalent to some category of multi-factorizations, some over some function of some smooth stack, whose critical locus is iconic to the moduli stack of semi-stable shapes on the non-compact Calabi seaport, given by the total space of this ranked vector boundary. So now, if you forget about the last OC factor, this is just the X boundaries. But now, by adding OC, we get to a Calabi seaport. So this is some sort of the categorical dimensional reduction. My point is, if you view that in the left-hand side, we view it as a categorical version of the Donaldson-Thomas theorem. On the automatic side, we defined this category. Our observation is that this behaves something like the category of A grains. Although the definition is more algebra geometric. First, it is not compact generative. So this is regarded as some analogy of the compact generation of the category of E modules with Dirichlet and Gates. Also, there are several important properties which we proved. For example, they satisfy some functorial properties. But this functorial property is not for the usual Hilbert push forward, but this is functorial for some Lagrangian correspondence rather than the usual Hilbert push forward. For example, if you consider map from the between smooth stacks, then we can associate some Lagrangian correspondence. And this category is more natural Lagrangian correspondence. Another important property is that, so in usual algebraic geometry, like Interpolf or Qpolf, usually when you consider non-proper map, then we can consider like it's you can consider the lighter joint of the pullback. But usually there's no lefter joint without shrink push forward. So such a push forward exists in the usually in the automatic side, like if you consider like power shields or D modules. In some cases, there are such a lefter joint. But in algebraic geometry, so there is no such a lefter joint. But in this formulation, we can construct such a shrink push forward. So the existence of such shrink push forward is extremely important. So this is also very important properties which I will not explain so much. But but this gives some close relationship between our formulation and the categorical DT theory. If you consider the compact object of both sides, so then they admit certain semi-orthogonal decompositions. So the precise formula is complicated, so I don't give details. But roughly speaking, so it admits SOD, where each part is the compact object of the limit category of the semi-stable part. So in fact, this is the category which actually categorifies the BPS invariant. For example, you take the logical case theory of this category, then it recovers the BPS cosmology. And in both sides, we have this semi-orthogonal decomposition, but the source of this SOD is quite different both sides. So in the spectral side, as I said, this is the spectral side, I said that this category is regarded as categorical part of the DT value. And in the homological DT theory, we have the certain decomposition, so-called the PBW decomposition into BPS cohomologies. So in the spectral side, so this serious ground decomposition gives certain categorization of this PBW decompositions. So then the source of this decomposition is so more combinatorial or representation theoretic. But in the automatic side, the source of this SOD is simple. So because in the automatic side, I didn't put stability conditions, so there are infinite number of the Harder-Nashman stratifications. And at each Harder-Nashman strata, there is one contribution to this structural decompositions. So this is the decomposition associated with the stratification. So although both sides admit almost similar SOD, but the source of the SOD is quite different. But nevertheless, because both sides admit this SOD, so the both sides of the category have the something similar size. This is one reason why we expect our conjecture. And this category has quite nice properties. For example, when G equals GFR and this rank and degree and weight, so this type is primitive. Then this category behaves very similar to the category of the derived category of coherent shifts with the stable Higgs moduli space, when semi-stable and stable are the same. As you know, so when the semi-stability and stability are the same, this is the case when the rank and degree are combined. So in this case, there is no strict semi-stables, and the moduli space with Higgs boundary is proper over the Higgs base. And of course, this is the Calabi-Yau because this is the formal equation. But when rank and degree are not prime, say for example, degree equals 0, then the moduli space is usually contain the strict semi-stable Higgs bundles, and this locus, the moduli space is similar. And in most of the cases, so these are the symplectic singularities, but they do not admit symplectic resolutions of singularities. But nevertheless, this category gives a certain categorical clevant resolution of such symplectic singularities. So in this way, this both sides admit quantum composition, which each space has quite nice categorical properties. And by this property, I would regard it as certain non-commutative version of the Higgs moduli space. Finally, I will state my main result about the Dolbeault geometric Langlands beyond the elliptic locus. So this is the main result which I use so post archive soon. But GF2 case is already appeared. In the case of G for GFR, it's an our PGR case. We have this equivalence of our formulation over the open subset. So this is the union of the elliptic locus and also this locus where the spectral curve has at least A-type singularities. A-type singularity is of this form and with projection given by the xy to x. But the point is that I don't assume the irreducibility of the spectral curve, so that I know any number of the irreducible components. So that over this locus, the moduli type of Higgs boundary is also not quite compact, and it also contains the strict semi-stable locus, and the original formulation has quite badly behaved. But indeed, our formulation works under such equivalence, even this elliptic locus. And in particular, so as I said, so I assumed this the vibration singularities, but this assumption is automatic in the GF2 case. That is, In the GL2 case, every spectral curve which is reduced spectral curve is automatically satisfies the previous assumptions. So that this is a picture of the spectral curve which is not irreducible but reduced. And in that case, we have the Dolbeault geometric Langlands correspondence of our formulation using limit categories. When it holds over the locus with the reduced spectral curves when G equals GL2, SL2, or PGL2. So yes, I will give some remarks about this. So as I said, so there are crucial differences between the behaviors in the elliptic locus and beyond the elliptic locus. Over the elliptic locus, the Higgs fibers are just the compactified fields. And as I said, because the spectral curves are integral, so stable and semi-stable are automatically the same. In particular, if you take the fiber product over this elliptic locus, the full Higgs moduli space, semi-stable locus, and stable locus are the same over this elliptic locus. So you don't have to care about the non-compact compactness, and the limit category is also same as the usual derived coefficient series. And over this locus, the question is reduced to the work by linking to show the derived equivalence for the compactified coordinates. However, outside of this locus, even in the GL2 case, if we have the reduced curve, then first in the spectral side we consider semi-stable one. But even for the semi-stable ones, still we might have some strictly semi-stable fixed boundaries. For example, we might consider the direct sum of the fixed boundaries, so that the switching fiber is not a scheme. And also, without stability condition, the hedging fibers contain infinite number of the Harder-Nashville strata, and it is not valid back. So in particular, about beyond the elliptic locus, we have these strict inequalities, and this is much bigger than the previous ones. So over outside this locus, it is quite difficult to consider the categories associated with the Higgs boundaries. However, our formulation is, so this is essential both to the formulation, not only the formulation, but it is also essential for the proof. In fact, we established many foundational results on the classical limit of the automatic side. And these foundational works are quite important. For example, first I gave definitions and some general properties. And I said, so there's some delta joint, some pullback factor. For example, it is important to see what is the image of this structure shape under the Dolbeault Langlands. So my answer is that this is the shrink push forward, the so-called hitching sections. But the hitching section is not the proper map outside the semi-stable locus. And if you consider usual push forward factor, then usually it is outside of the quotient shift. It is either quasi-quotient, quotient shift, and it is poorly behaved. But in our formulation, this factor makes sense and also preserve the compact object. And this object itself is very interesting to study. So yeah. But anyway, so the point is that we have a very defined object, and it corresponds to this structure shift under this correspondence. But the main difficulty of having such equivalence is to construct a factor. So this is the most difficult part. But a bit over the reduced spectral curves, we can also extend the Lincoln-Cohen extensions, and I'm using construction. So at least over the reduced spectral curves, we can construct a factor using Lincoln's Cohen extension. But the most difficult part is why Lincoln's construction gives a factor which we want. Because a priori there is no reason why the Cohen extension satisfies the weight condition which I wrote in the definition of the limit category. So this is the most difficult part, but nevertheless we can show that at least when the spectral curve has a type of singularities. And yeah, I'll try to extend it more general set. And then we can also show that Wilson and Hecke compatibility. The existence of Hecke operator is also important because if you import stability condition, usually Hecke correspondence destroys the stability conditions. But in our formation, we forget about stability conditions. And because we did, but still we can show that it admits Hecke operators. So this is very similar to the one recent by the Ocelot, Schiffman, Davidson, and Kinjo, showing the existence of Hecke operators of the BPS cohomologies. By defining the BPS cohomology using the moduli stack without stability conditions, and then construct Hecke operator and then restrict it to the BPS cohomology. So this part is very similar to this. And also the compact generation is very important. We can show that the both sides are generated by the Wilson operators, Hecke operators for these for objects. So these are the key ingredients. So finally, I have the summary and the future directions. The summary is that we gave a new formation with the Dolbeault Langlands conjecture. And this is inspired by the categorical DT theory. And gave a proof for this conjecture beyond the elliptic locus, at least for type techniques. And the future direction is that, of course, I want to extend to the pitching base, but this is, of course, quite difficult at this moment. So, of course, the original geometric Langlands conjecture is proven, but at this moment, there are many difficulties and obstructions to apply the technique and result to the Dolbeault setting. And also so I have only considered the usual Higgs functions, but we can also develop the theory for meromorphic or parabolic versions, but I did not think about anything about these directions. And finally, so for me, so my motivation is for Calabi-Yau. So the Higgs boundary gives some particular class of Calabi-Yau seaports, but I expect some more general statement, Dolbeault geometric type Langlands statement for any Calabi-Yau seaport. So even giving a formation is now very difficult, but I expect that this has some nice important implication to the negative geometry. So I stop here. Thank you very much.
So any question?
How do you expect to deal with an important cone in extending this to the full hitching base to 0? You have an important cone.
The fiber at the zero of the
Yeah, that's how do you?
Yeah, that is of course the next step I want to consider. Yes. One of the ideas that I want to first, the main difficulty is to construct a functor. And you have to construct a functor. So anyway, for each point, it should correspond to so-called the Hecke eigensheaf. There should be some point corresponds to certain object corresponding to Hecke eigensheaf. If we can construct certain family version of this one, then we can construct a functor. One idea is that, so I am trying to employ the classical argument by Dolbeault to construct Hecke eigensheaf. So he constructs such a sheaf using the Fourier-Lormont transform. And in fact, in our formation, we can also construct such an analogy of this one. And I'm now trying to, one idea is that to apply such a constructions. But still there are difficulties. So in the Lormont construction, I think he first constructs some modular space with sections, and then construct such Hecke eigensheaf of the modular space with hitching section, with some sections. Then finally it descends to the modular space of boundaries. So the descent to the final step is currently very difficult to do at this moment. But anyway, there are some ideas, but still there are several techniques, and I think we have lack of the several foundational works on this category. But anyway, of course, I will try to keep thinking.
Do you have, on the spectral side, do you have a free phase embedding from quasi-coherent shapes on each section?
What's your question?
So you can think of each section a version of offers quasi-coherent shapes. Let's say on function disk. In the usual setting, that's used as a generators.
Oh yeah.
So do you also have a free phase for counter?
Free phase one, I don't know about free space work, but at least we can show that the, so this is the image of the heating sections, and we can show that at least for the radius spectral curves. So this object, together with Hecke vectors, give a compact generator.
It's still a little different, right? So
Yeah, still different, but the difference coming from the outside of the reduced spectral curves. And I expect that so this object together with Hecke vectors, together with the image of the parabolic inductions, should give a compact generators.
or which sections are exactly
So
things that not hit by the parabolic induction. Right? And we can discuss more later.
Maybe we can discuss it.
Any other questions?
So can you say a little bit of expectation for parabolic version of your conjecture, even over elliptic locus?
So
Yeah.
yeah, to be honest, I didn't think anything about. Yeah, because I just wrote here because I listened to many talks.
Also, for parabolic version, you need different. You have different choice of weights, so you have even for semi-stable one, you have different like wall crossing, something like that. Anything you can expect for that kind of thing?
Oh, I see. So maybe you have many freedom of the choice of the stability condition. We also choice of the weight conditions in the right condition. But I think it is interesting point. There might be some choice of the kind of choice of stability conditions. Of the motion.
Sorry, do you expect all choices of some generic choice of weight can hold for your the
So if you, sorry, I didn't think about, so I cannot say precisely, but for some choice of stability condition, there might be some choice of some window conditions in the automatic side. And if you change the stability condition, then this condition also changes. And in some case it might be equivalent, but yeah.
Any other question?
The factor also maps BA brain to BB brain.
Yeah. I expect something like this, but I cannot say definitely now,
More questions? Okay, let's start speaker. So let's conclude the workshops. I would like to thank